Hey everyone, welcome to Dropbox Seattle, and thank you for joining us today. We're here for the Women Tech Makers event. And before we get started, I'd like to invite Margaret, who's one of the coordinators for the event and help us organize as well, to say a few words.
Sure. Hello, my name is Margaret Maynard-Reed. I'm the lead organizer of GDG Seattle and also the Women Tech Makers Ambassador. It used to be called lead for GDG Seattle. This is a joint event by GDG Seattle, Women Tech Makers, as well as Women in Data Science here, which Manaz is going to talk about what it is in a minute. And I just want to welcome everyone, and it's so great to see you all here.
Hi, everybody. Again, good to see everybody here. Thanks to Margaret for a great job. And really, this is our second joint event, and it's getting better. Seattle Women in Data Science was founded 2 years ago, just to bring women in data science together. And it's both for women who are in the field right now and they want to explore more skills and more areas. Also, it's a really good place for women who want transit to this area from other places or their student or whatever. Alice is gonna talk about it in detail. I'm not gonna go further. I just wanted to welcome everybody, and we're glad to have you over.
Great, thank you. And here you go.
Thank you, ladies. So we're going to get started with our first talk. Elise is going to talk about how to keep learning with the Seattle Women in Data Science group. She's been a volunteer with the group for a while, and I'll let her introduce herself a little more as well while I get the slides working. Thank you.
I don't have much else to say. Thank you for that introduction. My name is Elise. I am the volunteer coordinator for Seattle Women in Data Science. So if you want to get more involved with the group, please reach out to me through the Meetup site or through Slack. I have a ton of information about the group. So today I'm going to be talking about how to keep learning with Seattle Women in Data Science. I'm going to, how do I? So first I'm going to give a little bit of background about the group, and then I'm going to go into more detail about some of our events. We have career building events and we have study groups, and those are really good knowledge resources for if you're interested in getting into data science or if you want to solidify your knowledge. And I'm going to finish with more information about how you can get involved. So first, a little bit of background about Seattle Women in Data Science. We are founded in February of 2018. And since our inception, we have had a ton of variety of different types of events. We have technical talks every month where women data scientists in the field share their expertise and knowledge. We have study groups and career building sessions, which I'm going to go into more detail in the next few slides. But most importantly, we've created a platform where women in data science or people who are trying to transition into the field can communicate, share knowledge, share resources, and most importantly, support each other. So we've had a variety of career building sessions over the past year and a half. We've had Q&A sessions with industry professionals. We've had the CTO of JobScan. We've had data science manager from Textio come in and talk about how you can fix your resume, how to prepare for interviews. We've had speed mentoring sessions where we've had a group of mentors come in and mentees can go around in a circle and ask them questions about how to get into the field. We've had Q&As and events about how to prepare for interviews. We practice going through questions and how to structure your answers during an interview. And we've also had a Woman in the Workplace event where we talked about what it's like being a woman in a male-dominated field. We also have study groups. So these are longer-term learning resources where usually a group will get together weekly and go through, usually it's an online course, so the more popular ones were Andrew Ng's machine learning and deep learning, the machine learning and deep learning courses on Coursera. There was also a group who worked through the natural language processing with deep learning course that's offered through Stanford. We have an interview prep group where we get together and practice practice different skills for data science interviews. And we also have a book club right now. So currently right now, the study groups that we have going on right now, we have a book club, and we also, I think there's a new group that's starting the Andrew Ng machine learning course on Coursera. So if you're interested in going through that course, please take a look at our meetup page, and it is not too late to join. So the book club that is meeting right now is going through the deep learning textbook by Ian Goodfellow, Yoshua Bengio, and Aaron Corville. It's one of the most popular textbooks on how to get the foundation of deep learning that's offered through MIT. So please join this group if you're interested in getting a better foundation with deep learning. So here are some testimonials from people who have joined in our study groups. This is from Dora Dong. She has organized a machine learning and deep learning study group. I'm just going to read this. I wanted to grow my career in machine learning and deep learning, but there was no machine learning group at the time. Matt Now's encouraged me by saying you can create your own study group. Now I have organized 2 study groups, got a promotion at work. I met so many amazing data scientists in Seattle. If there's no resource, you can build your own resources. And that's from Dora Dong. Here are some more testimonials from group members. These are from people who did the deep learning course, Andrew Ng's deep learning course on Coursera. I would say the most important, the best thing about meeting as a group is you hold each other accountable. I know a lot of people have probably started these courses and never finished them. So if you want to be held accountable and be able to work through difficult concepts with other people, these study groups are a really, really great resource. And by the end of it, you become friends, and it's a really great experience. I've done both the machine learning and deep learning study groups, and I really recommend it. And we also have the interview prep study group. So here are some examples of the activities that we've done. We've done mock interviews. We've done practice whiteboarding problems. We practiced data structures and algorithms, and we also did a Kaggle boot camp. It's a pretty active group. Here is some feedback from Michelle, who attended some of our interview prep events. I attended my first interview prep night where I met some great people, and we practiced a whiteboarding problem together. That weekend, 2 awesome Seawoods people offered to help mock interview me on very short notice before a real in-person interview. I felt confident and prepared going into my interviews, and I ultimately landed the job. So yeah, it's a really great way. If you're nervous about interviewing, data science interviews are super, super hard. So reach out to me if you want to learn more about this group. We have a Slack channel. We have a WhatsApp group. So how can you help? There's a lot of different ways that you can get involved with our group. I put our social media on here. Please tweet at us, post us, tag us, use hashtags. Interact with us on social media. If you meet someone who you think would be a really great ally for our group, please introduce them to the group leaders. If you want to share your skills, we would love to have more speakers for our monthly talks. And we would also love to have more mentors to mentor people who are trying to get into this field. We want to get more women into this field. And also, think about organizing a study group. So if there's a course that you have started 10 times and you want that extra push to actually finish it and you want to work through it with a group, think about organizing a study group. The way that you can do this is you can join our Slack group. The way that you join our Slack group is you fill out a form on our meetup homepage, and you can message Oksana and Kritika. They are our event coordinators. They'll send you a form. You can fill out the form, and you kind of want to have an idea of why you want to start the study group, what materials you want to use, what do you want to get out at the end of this group, and logistics. And after you fill out this form and it's approved, we can help you with organizing, scheduling, where to meet, how to promote your group. We can also put you in touch with people who have led groups before. So please consider this. We would love to have more resources for people to learn. And that's it. Thank you.
Thank you, Elise. I'm sure you'll have some people from this group hopefully attending your meetups and learning sessions. Okay. Our next speaker is Sangeeta. She is Sangeeta is an engineer with the Alexa group and Amazon, and so she's going to talk about ML and integrating ML Kit with Android. Sangeeta.
Hi, everyone. This is Sangeeta. I work as a developer for Amazon with the Alexa organization. In my day-to-day job, I build Android applications on the Echo device. I also work on the companion app on Android and iOS. So as a professional Android developer, I'm always thinking about ways to build apps which are faster, smarter, and give like delightful, engaging experience to our customers. So when Google introduced ML Kit library in its I/O, I was pretty interested because it promised of allowing developers to build ML solutions on the application instead of on the service, that is ML on the edge. So what is it that got me interested about ML on the edge? What are the benefits? So I have listed them here. So let's take the use case of like Snapchat filters. If you need to like capture the image and apply some kind of filter on top of it, and if you have to do it with ML running on servers in the cloud, then that's of course latency of sending data back and forth. But if it's running on your device, then that's an easy latency win. Second is privacy of data. You all must have heard of the latest viral application, which allowed you to like capture an image and it applied some kind of age filter on top of it and made it happy. But the dark side of it is that all these images that were uploaded to the cloud were helping to train some kind of deep neural networks that come back to like target us in potentially malicious ways. Hopefully not. But of course, privacy of data is very important in this age, and running ML on the edge on your application helps in that cause. Third one is, of course, real time. In applications such as streaming or video games where you want fast processing on the device, this helps. Fourth is data usage. You don't have to send bits back and forth through half the way across the globe. Offline experiences to enrich your customers' experiences. And finally, just consider the like permutations and combinations of different experiences that you can build when you have your own custom ML models running on the device. So these are the benefits of ML on the edge. So here comes ML Kit. Hopefully you are all sold on the idea that ML on the edge is helpful and useful. So I introduced this library called ML Kit. Essentially, Google realized that they have this year-long of enriched data set, like 15 years and plus data, which they have finely tuned and trained and evaluated across their own personal applications. So they decided to wrap all of them into a nice and powerful, easy-to-use SDK and provide it to us developer community. It's essentially a list of APIs that you can trigger on your input and have the ML solutions applied right away. So let's not forget that there is still ML at the bottom. It's just abstracted from all of us. It is TensorFlow, a light version of TensorFlow called TensorFlow Lite, which is built optimized for mobile experiences. So consider a traditional ML solution. We need to gather the data, we need to cleanse it, then we need to train it, build it, evaluate it, tune it, deploy it, and finally predict data from that and provide to us customers. So Google removed most of the heavy lifting from here and just provided a library that you can simply call on your input data. So when I talk about ML Kit's APIs, we can broadly classify them into two forms. One is the base APIs, and the second one is the custom APIs. So base APIs are out-of-the-box experiences that are provided directly for us to use. And if you're not satisfied with any of the base APIs that are currently available, then you have the option to provide your own ML models to be used in your applications. So here we will be covering only the base models because I myself have not played with the custom models yet. So base models, they cover APIs for vision, language, etc. For example, like label detection in a hotel menu, or face detection, face features detection, landmark recognition, barcode scanning, all these like, these are like potentially day-to-day used, like mostly used ML stuff on applications. So I told you about quite a bit of APIs, but this is the official list from the Google Docs. Most of these are available on device and some are available from the cloud. The APIs available on the cloud, the difference is that they are more accurate because they are running through like more complex models, but they are not fully free of charge. I think the first 1,000 calls are something free. After that, you're charged for that. But of course, this is a pretty nifty starting point, and I'm sure like Google is working on providing more such base APIs. Right, so I talked a lot. So how does it look on the device? So I have an app running this on my mobile, but I thought I could not show it. So I grabbed a screenshot of it. So here we have Admiral Gracehopper, and when I run it through my Find Face Contour model, I see that it can accurately detect the image, the face, and also the bounce of the eyes, the ears, the lips, all that. So just imagine that this is the foundation for your Snapchat filter. On top of this, you can apply like balloons or glasses or any kind. Another example, detecting the text on an image. Given an image, it can accurately identify the bounds for each of the text and then also get what is the text on the image. Right, so let's walk through like a little bit of the code. So integrating MLKit on your application is very simple, and it can be done in 4 straightforward ways. Of course, it has the prerequisite that your application is integrated with Firebase. For the uninitiated, Firebase is kind of a backend infrastructure for building applications, and you can build it for iOS, Android, or any kind of web application. Consider the heavy lifting such as authentication, logging, analytics, crashlytics, all these being taken care of by this framework. So Google thought that machine learning should not be any different. It should also be available as yet another solution provided by this framework. So MLKit is available as part of Firebase. So how do we integrate with Firebase? It is as simple as going to the Firebase console and providing your application ID into the console. That's all. And after that, I think it gives you some JSON file which you need to hook back up to your Android application. That's the first step. Second one is adding the required dependencies for your MLKit use case. Third one is running your image through the API for processing, and finally passing the results. So it looks a large number of words, but I'll run you through it. So first one is connecting the app with Firebase Console. Like I told, just going to the console Firebase and providing your application ID. And after that, it gives you a JSON file, which you need to integrate back into your app. And that's it. It's connected with Firebase. Second step is adding the dependencies. Most of this is boilerplate Android code, but the thing to be looked at is from line 34 to 37. I had integrated like a couple of MLKit libraries, but depending on your use case, you can add the dependencies. Third one is, this is the meat of it. So how this works is, let's say you want to apply like a face detection or text detection on your image. You convert it into bitmap format and run it through Firebase Vision text recognizer. As simple as that. The interface has been provided by them. Firebase Vision process image in line 163. It's an asynchronous call, so it gives you a success listener and failure listener. And on your success listener, you get the result and process it. This is the meat of the data. It's like hardly like 20 lines of code, but most of this again is boilerplate code from Android. And finally, once you have the processed result, what do you do with it? In my case, I had applied graphic overlay on the image saying like red boxes, telling you like these are the bounds and these are the text. So that's what I've done. It gives you in terms of text blocks, and each text block has coordinate information in it, the text information in it, and the bounds information in it. So that's pretty much it. To give you a summary, connect your app with Firebase, add your MLKit dependencies to your build system. Third, run your image through the APIs provided in the library. And finally, parse the process results to do whatever you want. I don't want to touch a lot about the custom models, but it is a little more complex than this. You need to build your models and deploy it on the Firebase console. And using TensorFlow Lite, you can use it for your applications. But again, we can check that out offline. I'm not familiar with that. Yeah, that's all. Hopefully this has sparked a thought in your mind to use MLKit in your next application to make your apps smarter. Thank you so much for providing me this opportunity, especially because this is my first conference talk. So yeah. Yeah. Thank you so much. Yeah. If you want to geek more about MLKit or just want to talk to me, I'll just be over here. Thank you so much.
Thank you, Sangeeta. That was a pretty awesome first conference talk. So our next speaker is Arushi Prakash from Zulily. Arushi, you're here. Okay, awesome. She's going to talk about transitioning careers.
Hello. Yeah. Okay. Uh, so I'm Arushi. You can see me here and here. If you want to connect with me, feel free to tweet at me or add me on LinkedIn. When I saw the description for today's event, it said keep learning. And so I thought, talking about my journey where I sort of switched careers from chemical engineering to data science, and I kind of had to rebuild everything and re-educate myself, would be quite relevant to this meetup. And so before we get into specifics, just a brief, I did my undergraduate in India in chemical engineering. I flew straight to Seattle, where I started my graduate degree in chemical engineering. And during my degree, I was fortunate enough to do a few courses where I qualified for a minor in data science. And my research was pretty computational heavy. So I was doing physics-based simulations, but I was also doing a lot of Python-based analysis. And eventually at the end, I decided maybe I don't want to be a professor. And what I really want to do is, be in data science. And so I started my first job ever at Zulily this year. And so here, as compared to research, which is like fairly slow, and I'm not sure where my results would end up, work at Zulily as a data scientist is highly impactful. I'm making personalized recommendation engines. So when you go to the Zulily website to shop, you actually have personalized content, and I can be happy that I can make machine learning models that do that. And so there are a lot of people in my cohort that graduated with chemical engineering degrees or mechanical engineering degrees, and they also transitioned. And when I talk to them, they are doing like a whole lot of work. They are doing SQL, they're building different kinds of models. And so really, there is no real definition of data science or data scientist. So DJ Patil, who is, say, the first official data scientist for this country, said that that description is really amorphous, and we just need to grab the best tools we can and solve data science problems. But what that means for our field is that people come from everywhere. And so if you are a data analyst, or if you have an economics background, you can still make it in this field. The majority is not computer science. It only accounts for 20%. And the field is good for not having a majority, because you have a lot of people bringing in a lot of good ideas. And people usually hold a lot of different previous jobs. So that means that if you're in data science, you likely would have transitioned from somewhere. And that means that you likely would have to rebuild your career and re-educate yourself. And so how would you even go about doing something like this? And so this might be very specific to where I stand and how I approach my graduate degree, but hopefully there are lessons that everybody can take from this. And so the first thing that you want to do is, there's this famous Venn diagram that says data science resides in the center of math, computing skills, which are often called hacking skills, and domain expertise. And so when I started off, I was in a STEM program. And so I was kind of in the middle of math stats, and I knew a bit of Python. And so what I really wanted to do is push myself so that I approached more of the center, more of what people think of as data science, and convincing somebody that they would hire me, right? And so come to more of these events, look at other people who are also transitioning. There are a lot of online courses. And if you come from a field that is as traditional as chemical engineering, you'll realize that with data science, you can just educate yourself freely. With chemical engineering, you would probably have to pay hundreds of thousands of dollars to actually educate yourself. So really that should empower you to do more in data science, to have a lot of side projects for free, and then come for all of these workshops and study groups. And the second thing that I want to talk about, and this is something that not a lot of data science blogs out there or people talking about data science will cover, is the soft skills that you need to have to actually be successful. So now that I'm on the other side and I'm actually taking interviews to hire people as data scientists, I think the biggest difference between a junior and a senior data scientist almost always, not almost always, but comes down to communication. Like we as data scientists communicate a lot with non-technical stakeholders. So if you can describe a p-value to somebody, if you can describe a confidence interval to, say, your grandma, you can kind of make it. And then management, and this is something that I learned the hard way in my PhD, but now that I know how to manage my professors, know how to manage my own time, I can actually work more effectively as a data scientist. Because a lot of our problems are very open-ended and you don't really know where to focus your energy on. And finally, don't forget the network. I thought that, okay, I have friends in chemical engineering and they are not going to be useful, but now everybody's kind of transitioning into this. So hold on to those friends. Some will allow you to write guest blogs and some might connect you to different people. And so just a little snippet, I do attend a lot of these workshops. This is also my first talk here. And so we're all in the same boat and like kind of keep chugging along, and I'm sure like everybody's going to be successful. Cool. Thank you.
Thanks, Arushi. That was very inspiring in seeing people transition, because I personally know of a lot of people who are trying to transition from different types of roles, non-technical and technical. So hopefully a lot of people found that very interesting. Okay, so our next talk, kind of tying a bunch of things together that we've talked about, is learning together. So Krista is our next speaker. So let's welcome our next speaker.
Hi, everybody. I'm Krista Steuben, and I'm going to talk to you today about different formats that you can use for your different study groups. So first, just a little bit about me and my background. So I come from a math background, and after graduating from my master's, I became a data scientist or data analyst at IHME, which is a global health public research institute. And I have since transitioned into a researcher, which is almost like a data scientist position. I use data science to analyze trends in global health. Now, my background in math gave me a ton of skills that have been really useful in my jobs as a data analyst and as a researcher. But of course, there's always going to be more things that you need to learn. So these are kind of the 4 skills that I find are the most important for my job. For programming and statistics, I did get a really good foundation for that during my math program, but there's always more you can learn, and there's always more skills you can develop in those areas. For domain knowledge, so I'm working in global health. I had no knowledge of global health before I started working. So everything that was related to the domain I was working in, I had to learn on the job. And data storytelling. So being able to present the data and being able to present my analysis is really important. If you can do all the analysis, but you can't tell someone what you're doing, then did you really do your analysis? So building up these 4 skills were things that were really important to me. So the way that I built these skills was by joining learning groups, so joining different study groups. One of the great things about the place that I work at is there's so many people that are so smart and so excited to learn together that there's kind of a culture of coming together and creating study groups. So for each of these different skills, I joined 4 different learning groups, and each of them had kind of a different format. For programming, I was able to learn from an expert in the field. For stats, I joined a statistics book club. For domain knowledge, I joined a journal club. And for data storytelling, I joined a discussion group. So I'll go into a little bit more detail about all of these. So kind of the most traditional setting that most people are familiar with is the teacher-student relationship. And that's what how I used for learning programming. So there was somebody at my work that has a lot of experience with software development, and he provides lessons. So he will teach some stuff about programming, about like data structures and algorithms, about databases, a lot of different topics that typically people would get in a computer science background. This type of a format is really great if there's 1 or 2 people who are experts in the field and a lot of people who are more beginners or maybe intermediate that can learn from these experts in the field. It's also good for if there's kind of a well-defined, like this is what you need to learn and you learn it from that expert. One of the things about this is it tends to be a lot more structured, and it takes a lot of time and effort for the expert to create these lessons. So you need to find, either if you are the expert or you're finding an expert, you need to keep that in mind, that this is kind of a big undertaking for the experts. But on the other side, being the expert and teaching, you really gain a lot of those communication skills, and you really, by teaching, you learn your material so much better. For a group that has more varied skills and more of a wide range of skills, having a book club can be really useful. So the book club I joined was a statistics book club, and we will decide, we think of like 5 different books and vote on what book we want to study next. So these are all statistics textbooks. And then we go through each chapter, and for each chapter, somebody will volunteer to present. And the structure for this is really open-ended, and generally what we do is have each presenter decide what their format is going to be. So are they going to just lecture us the whole time? Are we going to work together on problems? There's a lot of different options you can do here. But really what we do is give the presenter full authority for that chapter. This is really great for groups that have various skills, because textbooks tend to start easy and get harder as it goes on. So beginners can take on those earlier chapters, whereas people who are more advanced can take on those more challenging chapters. And this kind of a group is really great for really doing a deep dive into your subject matter. Or a journal club, so this is how I really learned about global health. So in particular, I was working on a project on HIV, and there were a couple different people working on HIV at my work, and everyone was kind of looking at it from a different perspective. So what we did for our journal club was the group of researchers came together, and each week we would have somebody pick a recent publication that was recently published in a journal. And we would read the paper, and when we would meet up, we would talk about how are the methods, how are the results? Are there ways that we can use these results in what we're currently doing? And what I really got out of this was learning about HIV, not just from the perspective that I was working from, but getting the perspective of a lot of different people. This kind of a group is really great if you have a lot of advanced people or a lot of experts, especially experts that have perspectives from different angles. So for us, having the experts being able to find the correct academic papers to read, and then also being able to critique those papers was really important. And this is great for just learning about the domain that you're working in and learning about it from a lot of different directions. For learning about data storytelling. So data storytelling is a very broad subject. And so kind of aligning with that is we have a discussion group for data storytelling. So the way that that works, it's very loose format. So we meet together every 2 weeks. We loosely follow a book, but sometimes we'll look at different blogs or look at different like videos, or sometimes people will bring in their own data visualizations and will critique them, say, these are what's doing well, this is how you can improve it a little bit more, and just really getting kind of a lot of perspectives on what data storytelling is. A discussion group like this that has a very loose format is really great for something like data storytelling, where the topic is very broad. So many people have talked about data storytelling. You can get resources from a lot of different directions. And one thing that this discussion group brought about was, since it's such a broad topic, we have people from all different parts of the company joining this group. So we have people like me that are more on the researchers, data analyst side. We also have people that barely ever touch the data, but really talk with our funders and really talk with people that are in country that need to use our data. So we have a lot of different perspectives. And so bringing people in from all different parts of the company can be really helpful for getting a full picture of what you're working on. So what are the types of groups that I've been a part of? So I've learned from an expert, joined a book club, joined a journal club, and joined a discussion group. Definitely, these groups have helped me learn and have been really fun. And I definitely encourage you to find a group of people that are interested in some topic that you're also interested in, and try out a couple different formats and see what format fits best for what you're working on. All right, thank you.
Thank you, Krista. That was a pretty good complimentary talk to the one before that. So we're going to take a quick 5-minute break if anyone wants to run to the restroom, and then we'll resume after that. So, okay. Thanks, everyone. Hello, everyone. Can I have your attention before I start doing silly things up here? Do I have to do silly things? No? No? Okay. So we're going to get started. I realized in my excitement to introduce our awesome speakers, I forgot to introduce myself. Anyway, I'm giving the next talk, so I'll introduce myself. My name's Sarah. I'm a security engineer at Dropbox. I've been here for a little over a year now, and I'm going to talk about how and why we should continue to keep learning about the world. So I'm a security engineer at Dropbox. I've also worn a bunch of different hats. I was a researcher in grad school. I was a security program manager, and I was a security software engineer, and now I'm a security engineer. So a lot of the talks here kind of resonated, even though you hear security in all of them, they were still very different roles. I am the resident security cupcake of Dropbox. And while I'm not working, I do all of these other things. Most importantly, I'm very excited because I get to read a lot. I read a lot. So I'm going to talk a lot about what I read about today. So this talk is going to be a data waterfall, and I'm going to bombard you with facts. I'm kidding, I won't actually. So I want to talk a little bit about what we think about the world these days. And I think a lot of you will agree, when we think about the world, we think of that. It's burning all around us. Things are just kind of like not great. But the truth is it really like that? And why do we think that the world is actually burning? Well, there's a couple different sets of misconceptions. Obviously, I only have 15 minutes, so I'm going to go over like very few of them, but not all of them. So some of them, a lot of us, including me, have a tendency of thinking the world is divided into two. It's us and them. You think of economics, it's us and them, the first world and the third world. There's a developing world and the developed world. The other is, we think that the world is getting worse because we're consistently bombarded with information that tells us the world is getting worse. So of course we believe that the world is getting worse. And then we also keep thinking that the population is growing. All we see is all of the people every year, like all of our friends are having babies. There's so many people in the world, and so we're genuinely concerned about like, where are we headed with all of the scarcity of resources? Like, does the planet have enough to support everyone? But I will conjecture that the world's actually not that way, and I'll tell you why. So how is the world really? Like that. It's all unicorn cupcakes. Well, it sort of is and sort of not. If you think about the world and you try to build a fact-based worldview, which a lot of the data scientists in this room would love, you have to look at the data about all of the world and not just the selective data that is presented to us. Because that is when you create a true worldview of what the world really is right now. So, most of the world's population lives in middle-income countries. There is no developing and developed world anymore. We don't know that. I did not know that at the beginning of this year because I was like, well, I learned about this in high school. There's a developing world and a developed world. And I didn't bother updating my knowledge. The world has actually never been better than it is today. The number of child mortality has never been lower than it has been today. Human average age has never been higher than it has been today. The number of kids that are vaccinated, never been higher than before. The number of people dying of war deaths or war crimes, never been lower before. But, well, also, population growth is actually stabilizing. The UN predicts that the world growth is going to pretty much stabilize around 10 million or so in the next coming couple of by 2100 or so. But we don't know that. So why the misconceptions? Sad cupcake. Statistical facts are unnatural to most people. When you look at the worldview around you, you don't think of stats. You think of your personal experiences and how you have experienced the world, and hence those tend to be very biased. I mean, mine have often been very biased when I go to a third world country and I'm like, whoa, they have a metro system and it's better than Seattle? Thought this was a third world country, what? But those personal experiences tend to be biased. A lot of things that are newsworthy are events that are overly exaggerated. And also, something good and gradual change isn't news. I mean, honestly, if someone tells you here's a decline in child mortality and presents that to you on a news site every day, I don't think that's gonna capture our attention. So we don't actually look at slow and steady progress and think of that as actual progress in the world. And unfortunately, we also carry around a lot of outdated facts. I was reading a bunch of books earlier this year and last year, and I realized that really what I know about the world is from high school economics, because I was a computer science major, didn't really pay attention to a lot of economics. And I was shocked at how outdated my own knowledge of the world was. And honestly, ashamed as a technocrat, as a person in tech, where our responsibility is to build products for the rest of the world. So why should we care? There's a lot of reasons. If you want to have a conversation with me, I can sit down with you for hours and tell you why we should care. But for the sake of time, when you're trying to build products, you have to think about who your customer is. It's very basic tech fact, almost everyone knows. But here's an example. You're working on browser security, and you're trying to make sure people can differentiate between secure browsers and not secure browsers. And then you go ahead and add icons, remove icons. But who really is your customer? Is it people in Western nations, or is it people in the rest of the world? The UN predicts that by 2100, 92% of the world will be living outside of North America and Western Europe. Most of our products are built for Western Europe and North America. Most of the world is mobile. So a lot of people who talk about browser security and improving browser security features, I'm not trying to pick on them, just as an example, sorry, work on security. They are optimizing for desktop, but the rest of the world doesn't even use desktop. Another one of my favorite examples, obviously I'm in security, hence a security example, is we've done a lot of research on what are the most commonly used passwords. Only in the last couple of years has there been research on what are the most commonly used passwords in China. There is no research on what are the most commonly used passwords in Asia, South Asia, or Central Asia, or Africa. And there are so many people in those countries that actually have access to mobile devices and the internet. And the concept of an individual password actually doesn't exist. Often in those households, you'll have one person with a mobile device, and that device is shared. So how do we optimize for that society and those sets of people, especially when they're going to be the majority of the world? But we don't understand that. Also, is the data representative? I think this is a pretty classic problem of data science where we have our data sets, but they are limited or biased towards certain groups. And they're not just limited towards certain groups, but they're also limited geographically because there just isn't data that we are using to train our models from specific parts of the world. And we don't care to think that those are interesting or important because, well, they're the developing world. They don't have access to tech. But that's not true. Also, how do you decide what problem you should solve? Melinda Gates in her book, The Moment of Live, talks about how if unpaid work was a profession, it would be the largest profession in the world because the number of hours that are spent on that is just ginormous. So as a tech community, what are we doing to solve those kinds of problems? It's not about, here's an app to walk my dog. I mean, that's great. I love Rover. But just as an example, there are so many other problems. Like, how do you decide what to prioritize? When you're thinking of the next app idea, the next billion-dollar company, what are the problems you're going to try to solve? And in order to really understand what those problems are, you have to look at the rest of the world as well, because truly the world is your oyster. Sorry, that was cheesy, but still. Okay, so well, great, Sarah, you talked a lot about this. What do you do? So I want to talk about some of the things, some of the resources that I've used to learn about this. Obviously, books. There's a lot of really good books out there. Be very careful of data on random blogs if it's not cited. And if it's not cited, where did they collect the data from? Also, data can be represented very interestingly. I'll quickly mention one thing and I'll move on, but there's a graph about the average scores for SATs between men and women. There's a huge gap, it's like this big, between the average. But then if you chart out the total scores and like the bell curve of scores, it's actually a huge overlap and there's actually not much of a difference. And so the way the data is represented also changes your perspective on the data. So instead of always taking someone else's summary, look at the actual data. Anyway, here's some interesting books that I've read that have challenged how I think of the world. And if you've read all of them, that's awesome. I want to talk to you. They're pretty amazing. Highly, highly, highly recommend every single one of them. And there's a couple other resources here that you can use for data about the world. There are UN resources and reports that are published every year. There's a bunch of global health sciences reports published that actually give you a good idea of how the world actually works. And with that, I'm done. Thank you. So there's cupcakes outside in case you guys want some. I had nothing to do with that. Okay, I am going to introduce our next speaker, Angela. Angela is a staff engineer at Dropbox in our mobile team, and she's going to talk about UX for designing frameworks.
Hi, thanks, Sarah, for the introduction. So I went a slightly different route and wanted to talk about something that I've had some personal learning about recently and something that's really top of mind for me right now. So I want to talk about the UX of designing frameworks. This is like API frameworks, much like MLKit, and some others that you all are probably familiar with. Many moons ago, I actually started out as a primarily UI developer. I worked really, really closely with the UX designer for my organization. And in my mind, I've always associated UX with UI, maybe with physical objects, but not really about other aspects of my world. But recently, I've been working on re-architecting our mobile apps here at Dropbox. And as part of that, building frameworks to help support those architectures. Frameworks that have been used by the engineers here at Dropbox and maybe engineers outside of Dropbox as well. So what I want to start with first is just kind of level setting. Like, what do I mean by a framework? What is that? People have different ideas of it, and I just wanted to be specific here. So I went out to a website called Geeks for Geeks, which I think is a great name for a website. And, and I looked up what their definition for framework was, and it resonated with me. Framework is a skeleton where the application defines the content of the operation by filling out the skeleton. Or in other words, the framework only defines the concept, but an application further defines the functionality that is useful to the end users. And so this is what I'm attempting to do to help out my end users, which are other mobile engineers at Dropbox. And here's some popular frameworks that folks may have heard of, things like Node.js, React, Flutter, Electron, and one that I use as a mental bellwether for myself, which is Android Dagger 2, which is a framework that I use quite frequently, and one that I would argue maybe could use a little more UX in the way it works. The other thing I want to talk about, what is UX? UX is user experience, and then it comes back to thinking about who is your customer, who is your user. For frameworks, that's other engineers. Maybe engineers that you have a day-to-day experience with, and you can do code reviews with, and you can sit with, but it also might be engineers that you don't really have access to. There may be engineers that are some of you only see infrequently, and you really want to express your ideas to them. I found this lovely chart on the internet about some of the aspects of UX that I think of, and these can resonate with me from my background in UI. Things like, is it valuable? Is it usable? Is it accessible? Is it credible, which is a word I really hadn't thought of before, but I thought was really accurate and something really important for a framework. You want your engineers are using your framework to feel confidence in what you're building. However, this is like a lot. There's a lot to think about here when building a framework, and there's all the technology choices as well. So I sat there thinking about, like, how do I explain this to myself so like I can keep some priorities in my mind, and also how do I help express it to folks who are interested in what I'm doing, both my peer engineers and maybe leadership, who are sometimes curious what I'm doing. And so I came up with these two concepts, which really helped me kind of focus my thoughts, and I'm hopeful that they'll help you as well. And I started thinking about road signs and guardrails when I was designing frameworks. And to me, a road sign is something that I find helpful, something that shows a clear direction. What do I do next? Where do I go where I want to do this thing? And I use this example here because I'm often looking to where the Alaska terminal is, because that's where my frequent flyer miles are. And this was like a lovely example of, yes, I need to go to Alaska, and I take exit 1A. Perfect, I know what to do. The other side is guardrails. And this is, how do we keep the other engineers safe? How do I keep my framework safe? And so I found this beautiful shot that resonated with me because we recently went to Yellowstone, and Yellowstone has several of these lovely cliff drives without any guardrails. And, and I felt they were lacking. I would have appreciated them. And so this for me is something that I really feel confident about. And even I think of putting my shoes as an engineer, when I have a framework that I know is looking out for my best interests, I feel much more comfortable being innovative, much more comfortable taking risks versus maybe being very cautious about how I write in my code, maybe doing a lot of testing of both my code and the framework just to make sure it's really doing what I think it's going to do. Make sure I get it. So in a nutshell, for me, a framework should make it hard to do the wrong thing and clear to do the right thing. And so I'm going to jump forward. There's some example of road signs that I think are, like they help me, take a right here. This is which exit to go for Florence, South Carolina. And also the opposite side of like, don't go here. Like, this is not the place for you. And that can also be really, really helpful. Versus road signs like these. You have the one here that's like kind of being overly helpful. Like, there's a lot going on there, and you're speeding down the highway, and maybe you're tired after like 6 hours in the car, and you're like, yep, 90/60, that's the one for me. Like, there's a lot of parsing going on here, and you all may have worked with frameworks in the past that can feel this way. like, yes, I know it will do all the things. That's great. I just want to do the one thing, and so trying to avoid this, at least in the common cases, the standard flow of your framework. And then there's the other side, the stop sign, which I really want to know where somebody took this picture. I just found it on the internet, but it reminded me of a framework I've been using recently that deprecated the previous functionality, but the new functionality is supposed to replace it is still in alpha. And and I don't know what your organization, but our organization likes to avoid deprecated functionality, also likes to avoid alpha functionality when we push things out to production. And so it kind of leaves your users in a lurch of like, I kind of need to go forward, but I don't really know what to do. And that's also something would be nice to avoid. So what do I think about? And hopefully this maybe put some food for thought for you all too. When I'm trying to design these APIs, these clear frameworks, one of the things I really think about is going back to solid principles. It's something that I think about on a regular basis, but it's not always as front of mind. Ooh, okay. So if those of you who don't know solid, I definitely recommend going out and looking at that. The other things are clear, unambiguous naming. If your naming is not your strength, it's not my strength, lean on your peers, lean on colleagues outside of the organization if you can, and get as much feedback as possible just to make sure it's as clear as possible. Also consistency inside of your framework, either the APIs and the naming, but also consistency with your tech stack. So for example, I'm an Android engineer, and so being consistent with common Android APIs can be really helpful. The other thing I wanted to throw out here is using composition and inheritance. Oftentimes we want to lean on composition, and that is generally the best practice. I prefer composition myself. But times inheritance can provide those really clear road signs to your engineers, especially if you're thinking about life cycle and things like that. But most importantly is talk to your peers, get feedback from the other engineers using it, feedback from other engineers that maybe have design frameworks, and just to kind of get any ideas you can fleshed out before folks get this into production, and then maybe you want to do a major version change in the future that really changes the APIs. I want to talk about guardrails. I think you all kind of have my feelings about guardrails. I think they're very, very valuable. And so things I think about guardrails are the things that might trip up the engineers and make them feel less confident. As much as possible, abstract away thread management. Thread management, as many of you probably know, can be a bit of a handful. And as much as the framework can abstract that away as possible, awesome. It makes it more vetted. It's probably easier to test, those sorts of things. Deterministic data flow, immutability, so important that the people using your frameworks can understand and feel confident that the data is not going to have any weird side effects. And then use those visibility modifiers as much as possible. If your language of choice provides them, use it as much as possible. So it's really easy when the engineers using your framework do autocomplete, that they're only seeing the functions that are really available to them. And so, my closing thought is thinking about user experience when you're designing your frameworks and your APIs will hopefully let your engineers feel like these lovely ladies. Thank you so much.
Thank you, Angela. That was a very awesome talk. Okay, so we've heard a lot about organizing a bunch of different things, a bunch of different study groups. I'm going to invite Margaret to give our last lightning talk of the day about how to actually do the organizing. So you can go and if you don't find a group, which I don't think that will be the case, you can organize one yourself.
Great. Thank you. Thank you, Sarah. So my talk title is How to Organize a Machine Learning Study Jam. However, I'm probably going to focus a whole lot more on the content of the what, because quite a few previous talks already talked about the how part. And also, what is a study jam? So I've run study groups before at work or school, etc., for a recurring period of time, different sessions. A study jam is something special to GDG, Google Developer Group. This is something we will run worldwide in different cities and worldwide. And it could be just a one-day, full-day session, or it could be multiple. Like when I ran Android a couple of years ago, it was like 3 consecutive weeks. Actually, before I get to there, I want to talk a little bit about myself again. As you know, I'm the GDG organizer and Women Tech Makers ambassador, but I'm also a machine learning GD. So I used to be a program manager, turned into Android engineer, and now I'm a machine learning engineer, in particular for computer vision. So AI is the new electricity. Dr. Andrew said that in 2017. And Andrew Kapasi said, ML is the software 2.0. So in my opinion, every single engineer and non-engineer should learn about machine learning basics. And these are just some of the photos that from our machine learning study jam last year from GDG Seattle. And this is the study jam or study group best practices before, just like running any events, you remind the attendees of the prerequisite, identify some of the content, and during the study jam, we usually have talks and then also hands-on. I also invite coaches to come help if I have hands-on work. And then I also find that demos, very interesting demos, like maybe like Edge TPU, etc., will be helpful. And then afterwards, we will follow up and also use social media and photos to help encourage people to continue their studying. So now I'm going to transition talking about the content. So while I'm talking about how to organize a study jam, this material can be used to, like, if you want to study on your own and get started yourself. Because earlier I sang Sangeeta, you were talking about AI on the edge, right? You talk about ML Kit, you're talking about using the out-of-the-box API, etc. However, if you want to actually learn machine learning yourself and learn how to do the customized ML, you can learn on your own. Some prerequisites, in particular for like machine learning and deep learning, you need to learn some about Python and Python libraries. For example, basics of NumPy, Matplotlib, and Pandas for data manipulation. And you should also learn about calculus because you're going to hear a lot of these terms, and then algebra, linear algebra, and as well as stats. How many of you are engineers here? So when you write code, you need an IDE, right? Something to write your code in. Well, if you write machine learning code, especially as a beginner, I highly recommend you use Google Collab. How many of you have used Jupyter Notebook before? Almost all of you, right? So Collab is basically Jupyter Notebook running on Google Cloud, and it has free GPU and the TPU. As almost all of you probably know, when you do machine learning training, there's a lot of computation, matrix multiplication, and you do need to run it on a GPU or a TPU. And the TensorFlow is already installed. You can save and share from your drive, just like what you do with Google Doc or Sheet, etc. So it's very intuitive. You can also save directly to GitHub. So if someone sends you a link or even on GitHub, you click on it. In fact, if you go to tensorflow.org, you look at all the tutorials, all of them are written in Google Colab. So how many of you have already heard of Collab? Some of you. So give it a try. If you go to tensorflow.org, look at the tutorials, you'll see that. I have included a bunch of links here for you to take a look later on. So content, if you organize a study jam or study group or some sort, there are a couple of ways of finding the machine learning content, which is widely available these days, lots of resources. You can write your own, like myself. I write my own because I write blog posts and courses. So for me, writing my own, it's okay. You can use existing content. Like I said, lots of content is already available. You can also invite an expert to come give a talk in combination to all the content you've written yourself or some ready-made content already. You can combine all of these. So when writing your own content, like for myself, I can reuse my own code, my own writing from Medium, my own blog. It gives me the greatest flexibility because I can control, what to do. But not everybody can afford to just write your own content, right? And it's very, very time consuming. How many of you have taught a course before? You know how time consuming it is, right? To create like a 3-minute video, you spend days and hours and right? Or to give a 5-minute talk, how much time are you gonna spend on preparing that content? So that's not what I recommend. I would recommend you just start with the existing content. Start with tensorflow.org. And how many of you have visited tensorflow.org? A lot of you. So for those of you who don't know, TensorFlow is an open source library or a framework, right? It's for you to do machine learning, deep learning, or more than machine learning. However, it's more than just a framework. If you go to tensorflow.org, not only you're learning about the framework, you're also learning about the machine learning or deep learning basics. So start there. And these are the MOOCs. Udacity, Coursera, MIT all have deep learning courses. And the TensorFlow 2.0 is coming. It's going to be released soon. And all the 3 MOOCs have deep learning courses with TensorFlow 2.0. So it's very exciting. You not only get to learn the framework 2.0, but also you learn deep learning. And then Fast.ai uses PyTorch. It has 2 lessons on Swift for TensorFlow. And I want to point out Swift for TensorFlow just for a moment, because when we write machine learning code, a lot of people will write machine learning code with Python, right? And then when you look at TensorFlow, you'll see, oh, there's Java, there's this, that, the other, but Java is just a wrapper, right? But when you're actually writing the machine learning code with TensorFlow, you can write in Python, you can write it JavaScript, and you can also use Swift. And it's not just for iOS developers. It's actually the next gen deep learning language. So anyway, check out Fast.ai for Swift for TensorFlow. And Machine Learning Crash Course by Google. This one is what Google engineers will learn, this particular course. But Google open sourced it to everyone to learn. The benefits of this, what I like about it, you'll learn machine learning fundamentals. It has very nice animations explaining some of the tough concepts, right? And you will learn about how the learning rate works, back propagation, and it has a complete machine learning glossary. You have to keep in mind, if you do take this course, though, the TensorFlow code is slightly out of date. It's still using the 1.0, but great machine learning fundamentals. And quick labs, I will say we use this a lot for running the Google Cloud thing. For yourself, you need to have some points in order to do that. But if you come to our study jam, you'll get free monthly points. So again, a lot of the things is about cloud and is about machine learning as well. So Kaggle Learn, I know this is a joint event with Women in Data Science, right? So how many of you heard about Kaggle? Okay, all of you. So Kaggle Learn has a lot of great machine learning, data science courses. And this idiomatic programmer, I work with Andrew Furlich, and he wrote this really great tutorial handbook slides together with notebooks, particularly for computer vision. I recommend 2 books. One is by Francois Chalet, who wrote Deep Learning with Python. He is the creator of Keras. And then the other book is also pretty good, written by a machine learning GDE. And this is how to read research papers. When you learn machine learning, you have to read research papers. So papers with code is great. Not only you read the research paper, but also you get to see the code. All right. Thanks, everyone. And follow me on Twitter and GitHub and Medium. Thanks. Done with my talk. I also want to talk about.
Yes, I was going to say, let's thank all of our speakers one more time. There's a couple announcements. Women in Data Science would like you to know that they have their meetup tomorrow. So if you're inspired today, you should go check that out. Check out their meetup page as well. And then Margaret has more announcements.
Can I pull up my... So some of you probably going to ask if we're going to have the slides available. What I typically do is after the event, I will give you this slide linked to everyone's slides, so you have access to all of them. Some of the upcoming events for GDG Seattle, we have Google Developers ML Summit at Google Kirkland on September 18th. DevFest Seattle, September 21st, which is the largest annual event by GDG Seattle. I have not opened RSVP yet, but I will tomorrow. You will be the first one to know how to RSVP. And we have a Cloud Study Jam coming up in November, Kotlin Everywhere TBD. And then, we have the Women in Data Science events as well. So, is that it? Yeah, okay. And Yingqi is the organizer back there. And I know you already thanked everyone, but I really want to thank everyone for coming here, and also thank Dropbox for hosting us and graciously offer the venue and the food and drinks. Thank you.
Thank you, Margaret. Thanks everyone for joining us today. You'll have the speakers hanging around here for another 15-ish, 20 minutes. Make sure to grab them, talk to them, introduce yourselves if you haven't. And thank you for coming to Dropbox Seattle. And also, when you are leaving, there are gift bags outside for all of the attendees, and speakers will get you your gift bags as well, including Dropboxers. If you've helped volunteer today, please make sure to grab a gift bag for you. I want to thank all of the Dropbox volunteers as well for staying longer and helping out with the event. And thank you, Angie, Angela, Mariana, for being our wonderful timekeeper. Yeah, thanks, Margaret, and the Women in Data Science group as well. Thank you, everyone. Have a good night.